Hello. Okay, so today we're going to do some further integration of trig. So far we know that, well, when we derive, we've just got this little circle here. We know the derivative of sine is cos goes to minus sine. When derived, minus sine goes to minus cos. So obviously to integrate, we go the other way, or to find the primitive. So cos goes to sine, and sine goes to minus cos, and just following that pink circle. Okay, to start us off with some other trig functions and how to integrate them, we've got these known derivatives here. Tan goes to sec squared, cot goes to minus cosec cot. If you're unsure of these, just go ahead and prove them, okay? I'll just give you a hint. The first two are going to be probably quotient rule, and then the second two will be chain rule, where that'll be cos to the minus 1, sine to the minus 1. Okay, so give that a go if you need. So that leads us to the integrals. Obviously, just backwards, the integral of sec squared is tan, cosec squared is minus, because that minus is going to switch over, minus cot x, and so on, and just switching those minuses. Okay, so that's what we've got so far. Now we are going to work on something like integral of sine x. We know that's just minus cos, but I want sine squared x dx. Now this is new. I'll come down, I'll get rid of all that to give us some room here. I want the integral of sine squared x. That's a problem because before we had, okay, integral of sine, let's say we had some function in here. That was fine. That was okay. But this squared here, this squared makes it a bit harder. So we've got to come up with something else. We don't know how to integrate, well, let's call it a quadratic trig function. All right. How are we going to do this? What do we know about sine squared x? How can I write that? What trig identities can I use that will express that in some kind of linear form? Well, think about it, or I'll just tell you. We can use the old double angle formulas, okay? I know that cos 2x is equal to, what was it? It was cos squared x minus sine squared x, okay? Now here I've got the sine squared x, but I want to get rid of that guy. So remember we then changed it to, we changed cos squared x to 1 minus sine squared x, and then we said cos 2x equals 1 minus 2 sine squared x. Yeah. And we also could say that cos 2x equals to 2 cos squared x minus 1. And I'm just doing this one because this is going to help us integrate cos squared x. Okay, we'll do them both at once. Taking this one here, boom, boom, I could then say that sine squared x equals, just rearranging, a half minus a half cos 2x. Cool. From this one here, I can say that cos squared x equals a half plus a half cos 2x. Okay, so now I've expressed sine squared x and cos squared x I've gotten rid of that squared. I've gotten rid of the quadratic bit. So now what I'm going to do is rewrite this top line here as the integral of sine squared x dx is the same as the integral of a half minus a half cos 2x. All this I know how to integrate. So let's just do it. And I get the integral of sine squared x dx equals x on 2 minus, how do I integrate that? Minus cos, what did we say? Minus cos goes to minus sine, sorry. So I get minus cos goes to minus sine, so that's just a minus. Okay, minus, but the 2, that comes out as a half. So I get a quarter. So let's just write it as cos 2x on 4 plus c. I'm done. This cos should be a sine. So sorry about that. Bye. We'll use that guy there. And we'll say the integral of cos squared x dx equals, well, it's the same as integrating a half plus a half cos 2x dx. The integral of cos squared dx equals, well, that's x on 2. Cos goes to sine. So that's going to be a plus plus sine. What's going on here? Here we go. Plus sine 2x on 4 plus c. So now I've got two new integrals that I can do. I can now do sine squared x and cos squared x on top of all of these. So we got 1, 2, 6, 7, 8. Okay, we're just building up. So that's about it. I'll just do some quick examples. I'll just leave that there, and let's do an example. Let's find the integral of sine squared 9x dx. Okay, you don't have to go through the whole proof. You can obviously just look at this. It's a tricky one to remember, but this one here, I should say. Here, instead of x, just be careful that this might change. X is 9x. Yeah, so that's going to go to, that's going to go to 9x on 2. 9x on 2 minus cos 2x is 18x, isn't it? 18x on 4 plus c. Yep. So just careful. You might get a fraction in here. You might get something else in here. But just, without doing a full substitution, just eyeball it and give it a go. Some other trig functions that we might come across would be, well, let's call that EG1, EG2. Let's say the integral of, let's go sine x cos 4x dx. Okay. Just another complicated trig function. But how are we going to do this one? Well, I think that looks suspiciously like this guy, doesn't it? Whoop, let's do that in orange. F dash x, fx to the n dx, which I know how to do. That's easy. Alright, but it's not quite in that form, is it? Because what's the derivative of cos? Cos goes to minus sine. So what I want to do is plonk a minus there and a minus there, so everyone's in balance. And now I can just go for it. Integrate, that goes to cos 5x, cos to the 5x, I should say, on 5 plus c. But I've got that minus there, that negative. Okay, and obviously the negative c is just negative c. Okay, that's about it for today. Fare thee well.